Hi, hello. Welcome to our YouTube channel. So once again, I invite you, if you want to get updates of our newly uploaded videos, please click subscribe so that you'll get updated to our newly uploaded videos. All right, so this time we will discuss analysis or investigation of doubly reinforced rectangular beam concrete. So yung di-discuss natin last time is about singly reinforced. No? Analysis din yan. So we will have analysis of doubly reinforced session. So in this video, so we are given the beam dimensions, the width, the depth, the material properties, the tension, and the compression steel areas. So we will discuss on how to compute the balanced steel area of a doubly reinforced rectangular beam. Doubly, so balance, no? Most students kasi yung alam nila na balance, yung row balance na 0.85, FC prime, beta 1, 600, yun lang yung alam nila. No? But to tell you, that is only for singly reinforced. Kung doubly ka na, that's different. Alright? So, and of course, we will also see on how does the strength of a beam change, no? Or reacts with increasing number of tension bars. Okay? So, ito yung ating problem. So, given the following data of a doubly reinforced rectangular beam. So, beam width 410, effective depth 650, tension bar area 28 mm, compression bar is 320 mm, and then the concrete strength FC prime, Fy given, and the concrete covered to the 10 mm stirrups, okay, 40 mm. So yung unang tanong is the balanced steel area. Second is if, okay, by the way bali tatlo yung ating compression bar. Here I did not define yet the number of tension bars. Na? So in letter B, kung gagamit tayo ng tatlong tension bars, ano yung kanyang design strength? Again, the design strength is VMN. And kung gagamit tayo ng 6, example lang, 6 na 28 mm bars, ano naman yung kanyang design strength? Alright, tingnan natin. So ito yung ating beam sections. So we have 3 yan fixed, but yung tension bar, depende na. Letter B 3, letter C is naging ginawa kong 6. Okay, so 20 mm yung ating compression bar, and then yung ating tension bars are 28 mm. 10 mm yung ating stirrups, and then 410 yung width. The overall depth is 650 mm. The clear cover to the stirrup is 40 mm. Ito, 40 mm. And then we have the D prime. We will denote it with D prime. Yun yung, we don't call that cover really, but that is the distance from the center of the compression steel to the extreme compression fiber of concrete. And we also have, I will just call this D1. D1 siya. So, computin natin yung D1 at saka D prime. Okay? So, we have your D1. Your D1 will be, okay, tingnan natin. 40 mm plus yung, okay, 40 mm yung cover plus yung 10 mm na ties, okay? Plus kalahati ng 28 mm. Yun. So, that's 64 mm. D1 natin. Next, your D prime. So that will be 40 mm plus yung 10 mm na bar, the tie or the stirrup, plus kalahati ng 20 mm. So that is 60 mm. So your D1 is 64 mm, your D prime is 60 mm. So masosolve na natin yung ating effective depth. So the effective depth is 650 minus D1. Okay? So that's 586 mm effective depth. Okay? And the compression bar is 320 mm diameter. So that's 942.5 square mm. Okay? Sige. Unahin natin yung balanced steel area. Paano ba yung masolve? Ano ba yung formula? Can we use the row balance equals 0.85 MC prime beta 1 600 divided by Fy times the quantity 600 plus Fy? Actually, pwede mo gamitin yan. Pero may idadagdag ka pa. may idadagdag ka pa. That's too very, formula-oriented. Okay, ano ba yung principle ng balanced steel area? So that's the steel area na yung tension steel just reaches the stress of Fy. In this case, 345 MPa. Okay, yun lang. Yung tension steel stress is exactly equal to Fy, 345. Now, di ba may formula tayo for ito yung formula ng tension steel area, extreme fiber, 600 times D minus C over C. Equate natin yan to Fy. Yun. So by doing that, makukuha mo yung C, balance C. Actually, formula ito. Derive mo yan galing dito. Pag nakalimutan mo yan, don't forget it. I bet you should not forget this one. It's very important. Okay, so using that, formula yan, balance. No? So masolve natin yung C balance, 372 mm. Then masolve na natin yung A, beta 1C. Yung, by the way, your beta 1 is less than 28 yung ating FC prime. So your beta 1 is 0.85. Okay? So your A will be beta 1 times C. Beta 1 times 372. So 316.2 mm. Okay? So may A na tayo. Okay? So paano natin kunin yung AS? Pwede kang gumamit ng formula, no? Pwede kang gumamit ng meron ka ng A, magamit mo yung formula to get the value of omega, rho, but mahaba yan. Ito na lang. Okay, ito yung ating crack section. Ito yung ating depth ng compression block A. And then ito naman yung stresses. So the stress in concrete is 0.85 FC prime. So the total force in concrete is yun, 0.85 MC prime times yung area nito, AB. And then yung ating compression bar, meron tayo, CS, tawagin natin CS. AS prime, your AS prime is 942.5 times FS prime. Okay, take a look. Yung FS prime natin, hindi pa natin alam kung mag-yield yan. So leave it as is lang muna. FS prime, it can be equal to FY or not. But okay, never mind. I-check na lang natin yan later on. And then the tension in the tension steel here. Well, if you're computing the balance, automatic, yung Fs mo is equal to Fy. No? So sure na yan. Yung Fs mo dyan is equal to Fy. But I will just write it first as Fy, or as Fs. Okay? So alam natin, in this case, letter A, that should be equal to Fy. Kasi balance steel tayo. Yung Fs natin is equal to Fy to. Fs equals Fy. Alright, so by the way, ito yung moment arm. D minus D prime. Ito naman yung moment arm ng compression bar. I mean steel. Concrete, sorry. Ito yung sa compression steel. D minus A over 2. So, ito. Okay, as what I mentioned, this is yield. Of course, we are computing for the balance. Ito hindi pa natin to alam. Computing natin yan. May formula yan. Ito yung formula ng stress in the compression steel. 600 times C minus D prime over C. Ito yung D prime natin, ha? Na-compute natin kanina yung D prime as 60 mm. Okay. So C is 372 minus D prime over C. So that is 503.2 MPa. And that is more than Fy of 345. So mag-yield din yung ating compression bar. So at balance condition, both steels, of course, the tension steel yields. The compression steel is also yield. Fy din. Okay. So, after lang natin yung area, we don't need the moment. Makukuha na natin. Apply tayo ng equilibrium dito. Summation of force is 0. So, we have compressive force in concrete plus the compressive force in steel equals the tension. Okay. Ito yung ating CC. CS natin is AS prime Fy. Na-prove na natin na mag-yield yung compression bar. Ang T natin ay AS balance times Fy. Ang after tayo sa AS balance. Okay? So yun. Subject na lang yung formula, values nila, masosolve natin yung balance steel area. 7554. Alright. Did you get it? Okay? So yun ang balance steel area. Sa ano kasi, yung kung singly reinforced, wala kasi ito. Wala tong term na to, wala itong term na to. Kaya yung formula na 0.85 FC prime beta 1 times 600 and so on, base yun sa walang CS prime. You can follow the derivation of that, then wala yun. Hindi kasali yun. Kaya that formula cannot be applied kung doubly reinforced ka na. I hope nakuha nyo. Okay, let's have letter B. Anyway, ito yung ating AS prime. Ito na ngayon yung ating AS balance. Pwede mo yan gawing raw. Pero AS balance na lang. So ano ba yung gamit ng AS balance na yan? Of course, just like in singly reinforced, we can immediately tell if the tension steel will yield or not by comparing the area to that. Okay, halimbawa, in letter B, gagamit tayo ng tatlong 28 mm. So yung tatlong 28 mm is 1847. Tingnan nyo, square mm. No? Yung balance steel area is 7554. Napakalaki. Anong ibig sabihin ba ng balance area? No? So meaning, below this area, kunti lang yung steel mo. Siguradong talo talaga yung steel. Mag-yield yung steel. Pero kung yung steel area mo is beyond that area now, above that value, that tension steel area will no longer yield. So your Fs is no longer equal to Fy. So yun. So here, in letter B, it's only 1847. That's very small. Very small. Very, very less than AS balance. So meaning that tension steel will surely yield in letter B. Mag-yield ito. Alright, so your Fs will be equal to Fy. Ang hindi mo na lang alam ngayon kung ang compression steel mag-yield ba siya or hindi. Okay, sige, of course, knowing that it will yield, okay, gawin naman natin yung equilibrium. Compressive force in concrete plus the compressive force in steel equals the tension. Ito siguradong Fy ito Pero, okay, ito na yan. Ang ating compression bar, we don't yet know kung mag-yield. Iba yung kanina, baka malala yung kanina. Yung kanina sinunod natin, that's for balance. No, this time, iba na ito. We cannot use that anymore. Yung kanina kung naalala nyo, nag-yield yun. But that has nothing to do with this part. So ilagay lang muna natin na Fs prime. And then of course, the tension steel will yield. Okay. So ano yung gagawin mo dito? Kasi if you will leave this as unknown, there will be two unknowns, A at saka yan. Okay? Now, the common practice is, para ma-check natin without, hindi masyado siya mahirap i-prove, mag-assume na lang muna tayo. Assume tayo na yung Fs prime will yield. Assume natin. Anyway, this will just take a very few steps. Assuming that Fs prime equals Fy, then, okay, substitute natin. Yan, Fy na siya. So, masosolve na natin yung A. Yung A natin is 43.3. I-prove agad natin. So after that, check agad natin kung tama yung in-assume natin. Madali yan, kunin natin yung C. C is A equals A over beta 1. By the way, your beta 1 is 0.85. Then kunin mo agad yung Fs prime. Para malaman natin kung tama ba yung in-assume natin. So yung C natin is 50.9. Your D prime is 60. So makuha natin yung Fs prime. Alright, tingnan natin. Maliit masyado. Negative pa nga. Kasi yung pansin ninyo, yung C natin is less than D prime. Well, this will show us that the compression bar will not yield. Your Fs prime is not equal to Fy. So, wrong yung assumption natin. So, bali, ang ilalagay natin dyan, in terms of C, ito yung gagamitin natin for its value. Magiging in terms of C siya. Okay? So, ito yung magiging resulta niya. Okay, so ito yung C, ito yan siya. And then ito yung Fs prime, Fy, ang ilalagay natin dyan, ito. So C yung unknown, ang B naman, alam natin, A is beta 1C. Gawin din natin siyang in terms of C. Hindi na itong A nito wala itong kinalaman So dispose na to, wala na to. You don't use this one. Don't use this one. This is assuming it will yield. Nakita natin na it will not yield. But yung A dyan can be expressed in terms of C. So ito yun, A natin, beta 1C. And then ito naman yung AS prime, Fs prime equals AS Fy. Alright. So look here. Ang unknown na lang natin ay C. C yung unknown natin. So if you have your Casio 570 or higher, shift solve ka or whatever method yung gamitin mo dyan, huwag na lang natin i-discuss paano i-simplify yan dito. Matatagal tayo. So you can find it yourself. So that's just quadratic. Okay? So kung may shift zone ka, okay lang. So yung A natin is 80.5 mm. Okay? 80.5. Sorry, yung C pala. C, sorry. And then yung A natin, masosolve na natin. 68.4. Okay? So solve natin yung Fs prime. Substitute na natin yung C dito. So you will have here C is 80.5. That gives you 152.8. Okay, of course, expected. Talagang less than Fy siya. Okay? So yung Fs naman, tingnan natin yung Fs. We need to get Fs here. Kasi if you're using 2010, by the way, I'm using 2010 or 2015 here, we have to know if this is tension controlled or compression controlled. So we have to know the value of Fs. Kung maglampas pa siya ng, ano ngayon? 1,000 MPa. So by the way, the value is ito. Napakalaki, 3768. So it is more than 1,000 MPa. So therefore, this is tension control. Yung phi natin is 0.9. Na? Phi natin is 0.9. Okay? So, next, makukuha na natin yung nominal moment. The nominal moment is can be computed, no, as the moment caused by these two forces about here. The couple produced by the forces. So, ang pinaka-best dyan, mag-moment na lang tayo about this point. So, that will be C sub C times D minus A over 2 plus CS prime times D minus D prime. Ito yun. Okay? Substitute natin yung value. C sub C is 0.85 FC prime AB. No na yung A, ha? Alright? And then, ang ating moment arm, CS naman natin is AS prime, FS prime. FS prime is na yun? 152.8. Ito, AS prime, FS prime, D minus D prime. Okay? Then, masolve natin yung MN. Nominal pa yan. Ha? Ang hinahanap dito, design strength, PMN. PMN. So, your PMN, 0.9 yung phi natin, okay, is 313.2 kilonewton meter. So, tandaan nyo, 313 kilonewton meter. Alright. Okay. Let's have letter C. Letter C, ginawa nating 6 na 28 mm. Okay, 6 na ha. At tingnan natin kung mag-yield ba siya. So that 6 is 3694. Hindi, mag-yield pa rin. Ang balance natin is 7554. O, di ba? Okay. So, the tension still will yield. So, sigurado, your Fs equals Fy. Da? So, yun. Nga lang, problema ngayon, ang tanong ngayon, kung mag-yield ba yung compression bar? Just like in letter B. At ina natin. I will repeat what we have done in letter B. Mag-assume muna ako na mag-yield siya. Nag-assume ako ha. So, I'll just make this fast. So, nakuha natin yung A. Compute natin yung C. Check agad natin. Ayun. Check natin, no? Now, kung i-compute natin, look, that's 367. No? Your Fy is 345. So, in other words, mag-yield siya. Tama yung in-assume mo. So, swerte. No? So, kung tama, then yun na yung A natin. No? So, tama yung ating in-assume. No? Fs prime equals Fy. Your Fs, kumpitin din natin ito. Your Fs is, yun, 1,671. Lagpas pa rin ng 1,000. This is still tension control. Your P is 0.9. Okay? So, diretso na tayo. Hindi na tayo tatagal. Makukuha natin yung MN kasi may A na tayo. Ha? Ito yung A na to. Acceptable na siya. May A na tayo. Then, makuha na natin yung ating moment. Your Fs prime is equal to Fy. Look here. May Fs prime. Fas prime, Fs prime. Ang ginamit ko is 345 na. Kasi nag-yield na siya. Kanina kasi hindi nag-yield. No? Okay, so this is the nominal strength. And then the design strength is PMN, that's 598. Kanina is it was 313. Sa bagay, tatlo lang yun. Ito 6. Malaki talaga yung in-increase niya kasi hindi masyado bumaba yung fee. Yung fee natin naging 0.9 pa rin. Unlike kung maalala nyo, if you have watched the other video of mine, yung sa tension singly reinforced, no, dumami yung bar, lumiit yung fee kasi naging compression control na siya. Then ang nangyari doon, lumiit yung ating PMN. No? It's not worth it. Dito, it's okay kasi this is still tension control. Alright? Okay, so I hope you have learned something today. Doubly reinforced. I have more videos to come. Don't worry. Dahan-dahan lang. Every day I will try our best. Ito yung maganda sa lockdown. Magpo-post ako ng mga tutorial videos kahit anong topic, bahala na kayo pumili. Okay? Just don't forget to subscribe so that you will be updated with our ano man yung mga new videos na i-upload namin. Okay? So don't forget to click subscribe here. So thank you so much for watching, and just put a comment on what video they want us to do next. Okay? Thank you so much.